Hi guys, welcome to mock interview series. In today's video, we have a candidate who has recently completed routing and switching and security modules. So we'll be interviewing him on a different modules, different topics, right? But before taking an interview, we basically check resumes. So it's a resume format. So first of all, we check whether resumes are perfect or not. If resume is good, we proceed or we suggest them to make a modification in the resumes. So hi Pulkit,
Hello, sir. Good afternoon.
good afternoon. So could you start with your introduction?
Sure, sir. My full name is Pulkit Haggle. I'm from Delhi and I'm 24 years old.
Okay.
I completed my graduation in Bachelor's in Computer Applications, and then I completed my Master's in Computer Applications from Jain University, Bangalore.
Okay.
And then I enrolled myself in CCIE integrated program, in which I learned about the modules like CCNA, then CCNP, routing and switching, then advanced routing, automation, SD-WAN, and then comes to security modules, where we started with firewalls, Cisco firewalls and other firewalls, plus other security technologies like ESA, WSA, VPN, Splunk, SIEM technologies.
Perfect.
Yeah.
Okay. And I see a few of the certifications also you have done, right?
Yes, I recently completed 2 certification from Cisco Network Academy and 2 certification from Fortinet Academy.
Perfect. So let's continue with our questions. Pulkit, could you please tell me a few differences between router and switch?
Sure, sir. So both are networking devices and both are considered as intelligent device.
Okay.
Routers works on layer 3, whereas switches works on layer 2. Router routes the packets into 2 different networks, or we can say as it deals on WAN communication. And in switches, it forwards the packets in the same network but to different networking devices. So we can say that it works in a LAN communication. Routers maintains a routing table which consists of IP addresses, and according to these IP addresses only, it communicates to other devices. Whereas switches maintains a MAC address table which contains MAC addresses of the networking devices, through which it forwards the packets to the devices. Routers have per port broadcast domain, whereas switches have one single broadcast domain. But still, we can configure different broadcast domain on switches also using VLAN technology. Routers have per port collision domain, whereas switches have per port collision domain. If I'll give you a real-time use case scenario of a router, then we can say that we are connecting a small office or a home network over internet. So in this scenario, we'll use a router, whereas switches, we'll connect a printer to a home network or to a office network, so that all the nodes can connect to a printer by a single device.
Perfect. So let's continue with the other topic.
Sure.
So Pulkit, could you please tell me about types of ARP?
Sure, sir. ARP stands for Address Resolution Protocol, but it does not have any protocol number. It have a protocol type of 0x0806. There are 4 major types of ARP. First is standard ARP, second is reverse ARP, third is proxy ARP, and fourth is gracious ARP. Standard ARP, as the name suggests, it's the standard version of ARP, which helps to resolve the MAC address by the known IP addresses. It sends a broadcast ARP request and gets a unicast ARP reply. Whereas reverse ARP, as the name suggests, it's the reverse of the standard ARP. It is used to resolve the IP address by known MAC addresses. Usually there are RARP servers or RARP servers which responds to the query from the host which are sending to resolve the IP addresses. Coming to the proxy ARP, proxy ARP is used to resolve the MAC addresses in 2 different networks, or we can say whenever the ARP request is going from one device to another, and these 2 devices are differentiated or are divided by the router. So once a node A sends a ARP request and then a router receives it. Then the router checks whether it have the destination information or not. If it have the information, then it sends its own MAC address, that is known as proxy, to the host address. If it does not have any destination information, it drops that ARP request and it sends its own ARP query to the network so that it can get the information about the desired destination. And whenever the second ARP request comes to the router, then it sends its own MAC address as the proxy address to the requested host.
Okay, perfect. Little bit, could you tell me about GARP? What is GARP?
Sure, sir. GARP stands for Gracious ARP. It is used to check the duplicacy of the IP addresses over the network. Whenever there is a DHCP server and a DHCP client, a DHCP client requests an IP address from the DHCP server. Whenever the two stages of DORA process, that is discovery and offer, comes, whenever the DHCP sends the offer message to the client sends a GARP request with the same IP address as a broadcast message in the network to check whether this IP address that is assigned by the DHCP server is used by any other node or not. If it receives a reply, that means that this IP address is used by some other node. So it sends a deny message to the DHCP server. But if it does not receive any reply, then it binds its own IP address with its MAC address and sends an acknowledgement to the DHCP server. So this ARP fundamental is known as Gracious ARP.
All right. What other scenario can be where GARP could be used?
Whenever there is a new node that is coming in, or any node that is not functional, or if there is any interface down from the switch end or the router end and it comes up, then Gracious ARP packet have been shared to over the network.
Okay. I'll tell you one scenario where GARP can be used, and this can be one of the question which might come in your interview, real interview. Even in a HA configuration, when HA interface goes down, that time GARP will be used to interrupt to make the other side or the other interface to come up. So GARP will be used in HA as well. Okay.
Sir.
So let's discuss about EIGRP. Could you tell me something about EIGRP?
Sure, sir. EIGRP stands for Enhanced Interior Gateway Routing Protocol. It's an advanced distance vector routing protocol which is derived from IGRP. IGRP was distance vector routing protocol, but EIGRP is hybrid routing protocol. It's a layer 3 protocol with the protocol number as 88. It uses 3 different AD values. For internal route, it uses AD value as 90. For external routes, it's used as 170, and for summarized routes, it used AD value as 5. It works on a multicast address of 224.0.0.10.
Okay. What's an internal ID?
Internal ID is when the router, when a network is connected with the same router and it's in a same subnet and it's not going out of the subnet.
Okay. Could you tell me internal AD, external AD, and summary AD once again?
Internal AD is 90, external AD is 170.
Correct.
And summarized AD is 5.
Perfect. Go ahead.
EIGRP also support FLSM and VLSM. The metric size of EIGRP is 32 bits. We can configure, it is classful by nature, but we can configure as classless by using no auto summary command. The default hop count in EIGRP is 100, but we can configure it till 255. It uses 2 timers. Hello timers is shared every 5 seconds and hold on timer is shared every 15 seconds. EIGRP maintains 3 tables. One is routing table, then topology table, and then neighbor table. Routing table consists of the best route available in the network. Topology table contains the backup path or the second best path to reach the destination, and neighbor table contains the neighborship details inside the network. There are 5 regular packets in EIGRP and 2 conditional packets in EIGRP. 5 regular packets are hello packet, update packet, acknowledgement packet, query packet, and reply packet.
Perfect.
Hello packet is used for establishing and maintaining the neighborship. Query packet, update packet is used to share the routing information. Acknowledgement packet is the response to the update packet, query packet, and reply packet. Query packet is shared when there is any missing information about a certain route in a routing table. And reply packet is the response to the query packet.
Okay. So what's a multicast address of EIGRP?
A multicast address is 224.0.0.10. So.
All right. All right. Seems perfect, Pulkit. Today we'll have some question and answers on IPSec. Since you know, in a interview, mostly in a security perspective, if you see, most of the time they ask you questions from IPSec. It's one of the major protocol. So what is IPSec, Pulkit?
Sir, IPSec is a suite of protocols under IP protocol only. It gives you the it provides the encryption over the network. For encryption, it uses 2 protocols. One is ESP and second is AH. ESP stands for encryption.
Okay, little bit I would like to correct here. Is AH also used for encryption?
No, AH does not provide the encryption, but it is the protocol that is used by the IPSec.
Okay, go ahead.
ESP. ESP is a layer 3 protocol with a protocol number of 50. It provides encryption, integrity, and authenticity.
Perfect.
Whereas AH, it's a layer 3 protocol with a protocol number as 51. It does not provide any encryption, but it provides confidentiality. No, it does not provide confidentiality also. It provides authenticity and
Hash plus authentication.
hash plus authentication.
Yeah, correct. All right. So what are the IKE versions under the IPSec?
Sir, there are 2 IKE versions, IKV1 and IKV2.
Okay.
IKV1 have 2 modes. First, phase 1 that is known as ISEC MP phase, and phase 2 is known as IPSec phase. Whereas in IKV2, the phase 1 is known as IKE SA init, and second phase is known as IKE auth. In IKV1 phase 1, there are 2 modes, main mode and aggressive mode. Main mode have 6 messages and aggressive mode have 3 messages, but the work for both of the modes is same. In phase 2, which is known as IPSec mode, there are 3 messages, that is also known as quick mode.
Okay, taking you back to names that you told for the IKV1 phase 1 and IKV2 phase 1 and 2. In IKV1 phase 1 and phase 2, the names that you told, right? ISECM and IPSec, those are names.
Yes.
Okay. Those are not the protocols over there. Those are names over there. All right. So as you told, in IKV1, you have 2 phases, like phase 1 and phase 2. Under the IKV1 phase 1, you have 2 modes. Those are main mode and aggressive mode. Right. And phase 2 has quick mode. Correct. So could you tell me, in main mode and aggressive mode, what's the difference?
Okay. Sir, in main mode, there are total of 6 packet exchanges before the SA establishment happens. And in phase 2, in aggressive mode, there are only 3 messages that get shared for establishment of SA. So in phase 1, in main mode, the first message contains the SPI. So the initiator sends to the responder about the SPI, which includes the encryption, Diffie-Hellman, lifetime, and authentication.
Haggle process.
And then the responder replies its agreed SPI to the initiator. This is the second message. In the third message, the initiator sends to the responder about the key generated by with the help of Diffie-Hellman.
Okay, hold on here. In a first message, you told we have SPI.
Yes.
We have a Haggle process.
Yes.
And we have one more major character. What's that? It's a vendor ID.
Vendor ID. Yes.
Yeah.
VID.
So VID payload, right?
Yes.
Okay. We'll talk about payload here.
Okay.
So in like we discussed about Haggle, right? So Haggle comes under which payload?
Sir, Haggle comes under transform payload.
Okay.
And
Transform comes under?
Proposal payload.
Proposal comes under?
Essay payload.
Essay payload, correct. And all this information comes under which protocol? IPSec.
IPSec.
And IPSec works with UDP port number?
500.
With source, destination, or any one?
So after phase 1, anyone can negotiate for phase 2, but till phase 1,
not like that. Okay. I was asking about IPSec works with UDP port number 500, right?
Yes.
Is it for only source or destination or both 500?
I guess
both 5.
Both.
It's UDP port number 500 for source and destination both. Okay, no problem. Little bit more we have to understand. So coming to vendor ID payload. In a vendor ID payload, what exactly it contains? What is vendor ID payload here?
Sir, in vendor ID, they share the unique ID that is mentioned in the mentioned on the SPI about all the values that they agreed on.
Let me correct you. See, based on the Haggle process, SPI parameters are created. Those are in a cookies value.
Yes.
Vendor ID payload is actually a NAT-T.
Oh,
it's basically, it checks the support of NAT-T. Let's say in a VPN, let's say when we create a VPN, right? Between the two sites, in between the tunnel, if we have any translating device, then will your device support that condition or not? That is basically called as a NAT-T, NAT reversal.
Yes.
So under the vendor ID payload, there will be universal hash value. Now that hash value has to be same for all the vendors. Okay, it won't change for any vendor because IPSec is open standard protocol.
Yes.
Under the vendor ID payload, we'll have hash value, and that hash value is universal value. So every device, whoever connects through VPN, has to show a support of NAT-T that we can check in a vendor ID payload. If we see the hash value, it means it supports NAT-T. Further, if any translating device is there, from 5th and 6th message, it will apply UDP port number 4500. Right. Okay. So this was NAT-T. Tell me about 3rd and 4th message exchange.
Okay. So in 3rd and 4th message exchange, the key gets generated using Diffie-Hellman.
Okay.
So the initiator will generate one key and it will share it with the responder, and then responder will generate a key using Diffie-Hellman and send it to the initiator. So by sending these keys generated through Diffie-Hellman, they make a secure communication for the key transmission over the unsecured network.
Here we have something called as a nonce value. What is nonce value?
I cannot recall, sir.
All right, I'll reply it. See, nonce value is an unique number which is being shared while you are exchanging Diffie-Hellman key with your partner. So one site, while exchanging the Diffie-Hellman key, it will put some randomly generated nonce value, let's say 10. Other site reply is expected with 10 itself. So nonce value is used for anti-replay protection. The work of nonce value is to protect against the anti-replay protection. Right. Okay. So in a 3rd message exchange, we understood Diffie-Hellman generated keys with nonce value getting exchanged with each other. Now, tell me about 5th and 6th message.
So in 5th and 6th message, encryption and authentication take place. Once 5th and 6th message get shares, both the nodes is known as peers now, and now the IPSec essay establishment is done. The essay is bidirectional, so any one of the peers can start negotiating for phase 2. which is the main data transfer part. Till now, after these 6 messages, a security association have been built and communicated to each other and agreed upon it. And now it will shift to phase 2.
Okay. So one more thing related to third and fourth message we'll discuss. What is NAT-D?
NAT-D.
It's NAT discovery.
NAT discovery.
It basically tries to discover whether any translating device is present between two sites.
Okay.
If it has, from 5th and 6th, it will use UDP port number 4500. If not, it will continue with UDP port number 500 itself. So based on what parameters it understands, your device understands that there is a translating device in between a tunnel. Do you have idea about it?
So since IPSec does not, IPSec uses two protocols, ESP and AH, and these two protocols does not support either TCP or UDP. So that's why we use a NAT-T concept so that we can encapsulate these packets into UDP port number 500 or 4500.
Let me make my question clear. My question is, how does your device understand there is a presence of translating device between the tunnel?
Okay, so if the UDP port number 4500 goes, that means that there is a translating device and translation is configured. And if it goes as UDP 500, then it means that the translation device is there, but there is no translation configured on the device.
Perfect. That is fine. But what I was expecting answer from you was, in third and fourth message exchange, hash value gets generated based on source IP, source port number, destination IP, and destination port number. If that hash value matches with your destination source, a destination IP and destination port number, and source IP and the source port number, the cross hash value, if it matches on both the sides, source to destination and destination to source, if this value matches, it means there is no presence of translating device. If there is a change in a hash value, it means there is a presence of translating device which made a change in hash value. For example, static NAT, if we do, static NAT means change in a IP. IP got changed means hash value got changed. Hash value got changed, it means cross hash values will not match, and it will understand there is a presence of translating device in between. And further, fifth and the sixth message will be used with UDP port number 4500. Correct? All right. So little bit you have to understand in a deeper way. They will expect this type of answers from you, because we know that, okay, if NAT is discovered in between, then it will use UDP port number 4500. But they will also expect what's the reason behind how do they detect. So this process you have to explain. All right. Now let's discuss about fifth and sixth message. As you told, it is used for authentication, right? So tell me, will this message be in a clear text or will be encrypted?
Through fifth message, the encryption takes place, so it will not be in a clear text.
All right. So what makes that traffic encrypted over here? What was the previous exchange or any messages exchanged previously done before? I mean, before fifth and sixth message, what message got exchanged or what information got exchanged? So the messages of fifth and sixth were encrypted.
So when the hash value gets exchanged with each other using Diffie-Hellman, they make a secure connection over the unsecured network. So according to those values, it gets encrypted.
Diffie-Hellman is correct answer. And in Diffie-Hellman, basically Diffie-Hellman is a asymmetric key which generates a pair of keys. So they'll exchange the public keys with each other.
Yes.
And when both the sites has public key, they start encrypting our data. And when they receive the informations from each other, they use their corresponding private keys to decrypt it. So that's a reason why in a fifth and the sixth message, encryption gets started, right?
Yes.
Okay. Fifth and sixth message, are authenticated when they complete these messages. Before completing a message, the authentication does not complete and phase 1 is not yet completed. Established. Correct. That you told earlier. All right. So, what could be a difference between aggressive mode and a main mode? Could you please tell me on it?
So we have discussed the main mode, which have 6 messages.
Correct.
In aggressive modes, it's a combination of message. So in main mode, the message number 1, message number 3, and message number 5 goes as a single message in aggressive mode from initiator to responder. And grouping of message 2, message 4, and message 6 from the main mode clubs to a single message and goes as a message number 2 from responder to sender in aggressive mode. And then again message 5 from main mode sends back again to the responder with encryption to complete the SA establishment.
Let's consider we have 3 messages in aggressive mode, right?
Yes.
So here, as you told, like almost all the parameters are exchanged in a first 2 message exchanges itself to establish a tunnel.
Yes.
Phase 1 tunnel, right? So here in phase 1 and in a first and the second message exchange itself of a aggressive mode does not contain any encryption.
Yes.
It shares Diffie-Hellman and identity.
Yes.
The main part is identity will be shared in a clear text,
Yes.
which was supposed to be hidden.
Yes.
Right. So that part is being secured in a main mode. Right. In aggressive mode, this identity part is not secured. Compared to main mode, almost all the parameters that are required to create a tunnel is shared in a first message itself and a second message. In a second message, it gives a confirmation with hash value, and in a third message, it also sends the hash value from the initiator to a responder as a confirmation. But remember, Diffie-Hellman keys are already exchanged in first 2 messages.
Yes.
That's a reason the hash value, the confirmation which goes from initiator to responder will be in encrypted format. Generally, there are multiple blogs on a website. I don't know, like either candidates are misunderstanding it or whatever the reason is. They understand that aggressive mode does not support encryption, but it's not like that. First 2 message exchanges with identity are not encrypted. After exchanging the Diffie-Hellman keys, after that, the third message is encrypted. Because Diffie-Hellman is being shared. Okay, that's the major difference that you should indicate in your interview, right? So that's all, guys. In today's interview, we understood about the IPSec, like what type of questions might come in your interview. So you need to have a deep knowledge on a IPSec, right? So IPSec is one of the most important topic when you go for a security prospective interviews. This can help you to grab the opportunity, right? So you need a deep knowledge on IPSec. Thank you, guys. See you in the next series.
Thank you, sir.